Greetings to all and a warm welcome to the tutorial series on remote development with PyCharm and Cloud Code. Within this tutorial, we will delve into the advantages that arise from utilizing Cloud Code alongside PyCharm. Remote development is the basic idea that developers can work on software projects from anywhere in the world. Nevertheless, the majority of software developers continue to operate within their local environments. They check out the source code locally, write and debug new code using their local IDE, and build and test the software on their own machines. Once satisfied with the code changes, developer commit them to the version control system, enabling other developers to subsequently check out the modified code. According to the developer ecosystem survey which happened last year, 53% of the developers have edited code on remote machines. According to a survey, 35% of remote development users expressed that their computers lack sufficient performance to meet the demands of their work. Interestingly, 68% of individuals engaged in remote development expressed a desire to have flexibility of accessing their development projects from multiple devices and locations. You may be wondering about the advantages. Rest assured, there are numerous benefits when compared to working on a local machine. With the ability to work on software projects from the comfort of your home or any location worldwide, all you need is a device to connect to your remote workstation and you are all set and ready to go. Unlock the potential of remote machine and eliminate the need to invest in costly hardware. Take inspiration from platforms like Google Colab, a hosted Jupyter notebook service that offers free access to compute resources, including GPUs, without any setup requirements. Eliminate the concern about laptop theft by embracing remote development, thus mitigating the risk of source code exposure. A growing number of companies are now endorsing remote development, indicating that cloud development will undoubtedly play a crucial role in the future of software development. Curious to know about Cloud Code and how it can benefit you? As a developer, the majority of your time is likely spent within the IDE. To streamline your Kubernetes development workflow, you can enhance your IDE by incorporating Cloud Code, simplify the process of building, deploying, scaling, and managing Kubernetes infrastructure and application, making it effortless and efficient. In order to maintain your focus on coding, it is worth considering how the extension you integrate in your IDE can minimize context switching. Cloud Code offers built-in functionalities specifically designed to minimize context switching. With Cloud Code, the process of building containers and deploying them to Docker Desktop or Minikube is simplified. Additionally, Cloud Code extends its support to remote cluster, allowing you to offload CPU and memory resources from your local machine. By utilizing Scaffold, Cloud Code empowers you to conveniently set breakpoints within your code. Once a breakpoint is triggered, you gain the ability to step through the code, inspect variable properties, and effortlessly view container logs. Ready to dive in? Let's get started and make things happen. In this tutorial, we are going to install the Google Cloud SDK and Google Cloud Code plugin. I recommend following the official documentation for installing the gcloud CLI. You get multiple flavors to choose from: Linux, Debian, Ubuntu, Red Hat, Mac OS, Windows. So we are going to use gcloud in Mac, which is already installed. So I'm going to run gcloud version. And as you can see on the screen, it's already installed in my machine. You will need to install the GKE gcloud auth plugin binary on all systems where kubectl or Kubernetes custom clients are used. Run the following command: gcloud components install GKE gcloud auth plugin. As you can see, this plugin is already installed in my machine. Now let's go ahead and configure Google Cloud CLI with Google Project. Now that we have the SDK installed, we need to configure the Google Cloud SDK to talk to a specific project. We use the gcloud utility from the installed SDK for CLI based Google Cloud access. I'm going to type gcloud in it. You'll see the following prompt. So as I have one project already configured in my CLI, I will go ahead and create a new configuration by choosing option number 2. So it's going to create a new configuration. I'll provide the configuration name as JetBrains. I'll choose my Gmail account, which is option number 1. Make sure you are already logged in to your Gmail account. I will choose the option number 1, the cloud project, JetBrains 387607, as I have already created this project in the Google Cloud Console. Great, the SDK has been successfully configured. Allow me to demonstrate a rapid procedure for generating a fresh project in Google Cloud. Access cloud.google.com/console and navigate to the hamburger menu. Proceed to dashboard, then select create project. Input the desired project name and click on create. Please note that the provisioning may require a few moments to complete. Now let's move to PyCharm and install Google Cloud Code plugin. Make sure you have installed the latest version of PyCharm on your machine. For this, we are using the 2023 1.2 version of PyCharm. Once you open PyCharm, click on Plugin section, search for Google Cloud Code and click on Install. Once installed successfully, make sure to restart the IDE to take effect. Prior to proceeding, I'd like to mention that Google regularly introduces fresh iteration of the Cloud Code plugin. To access the latest releases, head over to the JetBrains marketplace and search for Cloud Code. For this tutorial, we are utilizing version 23.5.1-222. Additionally, you can visit the official GitHub page to explore the most recent release notes and applications. In this tutorial, we will utilize Docker Desktop. Please ensure that you have installed it on your machine before proceeding. To work with Kubernetes, navigate to the settings and activate Kubernetes, which will initiate the single node cluster. Let's now begin by creating a new project. You will observe 3 new options appearing on the left. You can run your project in Cloud Run, which is a serverless offering of running Kubernetes in Google Cloud, or you can choose standard Kubernetes where you can run your code locally or in a remote GKE cluster. Cloud Code plugin has already created some sample code in Django and Flask. We'll be exploring one of them. But if you're interested in maintaining your custom projects, then follow the official documentation provided by Google. They have clearly explained step by step. Now let's go ahead and create a new project by choosing Python Django Hello World as our base sample. I will name the project Hello World. Once you click on create, it will start cloning the project. As you can see, you will get a README file that contains all the information about your project and how to run the application. They have explained clearly how you can set up the application using Minikube, how you can run your application in GKE cluster, how you can deploy your app. So on your left, you can see the project structure created by the Cloud Code plugin. Here the files have been distinguished between 3 parts like scaffold.yaml file, schema file containing the scaffold configuration, Kubernetes manifest directory which contains the K8s YAML files, SRC directory contains the Django source code. Here the main center of attraction is the scaffold.yaml file. According to Google, Scaffold is a tool that handles the workflow for building, pushing, and deploying your application. You can use Scaffold to easily configure a local development workspace, streamline your inner development loop, and integrate with other tools such as Customize and Help to manage your Kubernetes manifest. The major benefit of using Scaffold is fast iterative development. Scaffold comes with highly optimized workflow for local and remote deployment, giving you the flexibility to develop against local Kubernetes cluster like Minikube or Kind, as well as any remote Kubernetes cluster. Scaffold is part of Cloud Code, so it becomes very easy to manage from the IDE itself. Now let's focus on the scaffold.yaml file. There are 2 major operations happening over here. One is build and one is deploy. If you observe line number 5, it is going to perform a build operation by creating the Docker image. So it is going to look for the Docker file which resides under the SRC directory. Same as it is defined in the context section at line number 10. It is not only the Docker file, Scaffold has multiple support like Docker, Zip, Bazel, Co, Cloud Native build packs. So I definitely recommend you to follow the official documentation of Scaffold to know more. The good part is that you can build your Docker image using locally installed Docker, or you can execute the same operation in Google Cloud Build as well, whichever suits your need. Now moving ahead, if you observe line number 13, the deploy section is going to apply the Kubernetes manifest files which are residing under the Kubernetes manifest directory. So let's now explore the deployment.yaml file. So basically it's going to run the application with one replica running at port number 8080. The service YAML file is going to expose the deployment using type as load balancer with target port to 8080. Now let's move ahead and give a glance to edit configurations. So as you can see, right now I'm going to deploy to the current context, which is Docker Desktop. So I have already installed Docker Desktop in my machine. So all the operations are going to happen over there. You can observe the watch mode. So there is something like on demand, on file save. We'll choose on file save to build and run the application whenever there is a change in the SRC directory. In advanced settings, you can customize the kubeconfig location. Along with that, you can set environment variables, specify resource deletion timeout, which is by default 2 minutes. You can also fine tune the logging verbosity by changing the settings according to your needs. Under build and deploy, we will look for the scaffold.yaml configuration. This will take the instruction from the YAML file to do further processing like building images and deploying the K8s manifest. As I was talking previously about build features, you can choose based on your requirement. For now, it's going to be built locally in Docker Desktop. So we are done with the edit configuration. I'll click on apply and then OK. Now I'm going to run the application. You can observe in the console that the build process has been initiated and it's going to take a few seconds to complete. So I'm going to speed up the video. Okay, as you can see, the build and deployment are complete and the port has been forwarded to localhost at port number 4503. Let's check quickly in the browser. Cool, the application is running and this is the default landing page. So this is just the beginning. So let's go ahead. In our next video, we are going to create a REST-based to-do application using Django REST framework. In this section, our main focus is on writing CRUD APIs. CRUD stands for Create, Read, Update, Delete. So let's begin. First, I need to enable the Django support. I'll click on PyCharm, Settings. Under Languages and Frameworks, I'll click on Django. Click on Enable Django Support. Provide the project root path, the settings.py and manage.py. Once done, click on Apply and then OK. Next, I'm going to create a virtual environment. I'm going to create a new virtual environment under the project root Hello World. Once the virtual environment is created, I will go ahead and install the requirements.txt. Next, I will install the Django REST framework. Once the package is installed, then I will go ahead and update my requirements.txt file by running the following command. Now I'm going to create a new Django app. So I'm going to click on Tools, then run manage.py task. I'm going to create a new app by typing start app to do. So my app name is going to be to do, which is going to have necessary views and models and all different kinds of files. Now open settings.py file which resides under src hello world. Make sure to add To-Do and REST framework under installed apps. For local development, we'll be using SQLite 3 database. Make sure to add this section at the end. Once done, open manage.py again and type migrate. The default Django tables will be created. Once we are done with the migration, I'm going to create a new model and name it as to-do list. This model is going to contain two columns, content and created at. Now go ahead, open manage.py and run make migrations to do. And once migration files are created, then I will run the following command migrate. Now I'm going to create serializers.py file under to-do app. Serializers allow complex data such as query sets and model instances to be converted to native Python data types. I'm going to create a class called to-do serializer which inherits model serializer. The model serializer class is same as regular serializer class, except it automatically generates a set of fields for you based on the model. So once I'm done with the serializer, I'm going to write the business logic in views.py. So I'm going to create a class to do create list API view, which inherits list create API view, and it contains the get and post method handlers. After that, I'm going to create another API to do API view, which inherits retrieve, update, destroy API view, which contains get, put, patch, and delete method handlers. If you have observed from line number 13 to 19, we have overridden the create model mixing create method, which takes care of creating new model instances. We have customized it to return a custom JSON response. Next, we will go ahead and register the routes in urls.py. Before moving ahead, make sure to add db.sqlite3 in the docker ignore file. So when the image is getting built, it's not going to pick it up. And you need to get inside the container and run the migration command manually. But for this tutorial, we can ignore this as we are not working in a production environment. Make sure to take this point in mind when working with a real project. Now I'm going to run the application. Once the application is up and running on port 4503, you can immediately see the effect in the browser. Application routes are rendering properly. Let's test out all the APIs to check everything is working as expected. I'm going to open Postman and try creating the new to-do item. I will perform post and get operations on to-do create list API view. You can see the results. The API is working fine and we got the expected response. We created a few sample to-do items and then retrieved the list through the get handler. Let's now try out the to-do API, which performs multiple operations like get, update, and delete. In the delete method, we are not going to get any response back, and you will get a status code of 204 no content. Okay, we are done with our APIs. What's next? There's something Cloud Code plugin provides that's called console logging. If you want to check the container logs in a standard way, then you can run the following command in the terminal. First, I will run kubectl get pods to get the list of pods running in my cluster. Then I will run the command kubectl logs followed by the pod name, which will show me the logs. One of the good thing about the Cloud Code plugin, they have a feature called Kubernetes Explorer where you can stream the logs directly without going through the terminal. Not only Kubernetes Explorer, but there are multiple things provided by the plugin: cloud databases, Cloud Run, Secret Manager, Cloud Storage. So make sure to go and check those out. In Kubernetes Explorer, you can easily connect with local or remote cluster and easily stream the or tail the logs and perform multiple operations on deployment, replica set, etc. While running the code inside the container is so smooth, the same goes for debugging. What I'm going to do next, I will add a breakpoint inside my code to inspect what's happening. If you observe carefully, after line number 16, we are capturing serialized data, which we are going to receive from the post request. Now I will go ahead and click on the debug. Okay, the Python debug container is running and needs to map with the remote path /app. So I'm not going to change anything. I will simply click on OK. The debugger is successfully connected. Let's try to create a new to-do item and see what happens at the breakpoint. As soon as I trigger the post request to create a new to-do item, the debugger immediately catches it, and I will try to click on step into my code. Cool. You can see we have captured the data being passed in the serializer. That's how debugging got simplified. In the next video, what we are going to do, we'll be focusing on creating a new Google Kubernetes engine cluster in Google Cloud and try to run the entire workload over there. We are now going to set up Google Kubernetes engine. Make sure you have a valid Gmail account. Visit this URL cloud.google.com/console. Click on the hamburger menu, move towards Kubernetes engine, and then click on clusters. Enable the Kubernetes engine API. It will take a few seconds to initialize. Now click on create. Switch to standard cluster. Provide a cluster name. I will go with the default. Location type is going to be regional. Check on specify default node location. I will choose all the 3 locations. I will choose the regular channel and choose Kubernetes 1.25.8 version. Now under default pool, change the number of nodes to 1. We have 3 zones. Each zone will consist of 1 node. So the total is going to be 3 nodes. Under nodes, make the following changes to reduce the cost. Change machine type to E2 small. Boot disk size to 20 GB and enable spot VMs. Under security, choose allow full access to all cloud APIs. Under cluster networking, check on access control plane using its external IP address and enable control plane global access. The cluster should be private. Also provide the control plane IP range. Make sure to enable data plane v2. Enable control plane authorized network. GKE data plane v2 is a data plane for GKE and Anthos cluster that is optimized for Kubernetes networking. In the authorized network, we'll try to access the cluster from the public internet. From a security standpoint, only give a static IP address that is limited to your organization. Security is a big topic and it's a subject of its own. Under cluster security, make sure to enable workload identity. Workload identity allow workloads in your GKE cluster to impersonate identity and access management service accounts to access Google Cloud services. We are done with all changes. Now let's proceed by clicking on create. It will take a couple of minutes to launch the new cluster. Meanwhile, we can focus on creating CloudNet. CloudNet provides outgoing connectivity for the following resources: Compute Engine virtual machine instances without external IP address, private Google Kubernetes Engine cluster, Cloud Run instances through serverless VPC access, Cloud Function instances through serverless VPC access, App Engine standard environment instances through serverless VPC access. Click on Get Started. Provide the gateway name and the region. Click on Create a new router. Provide the name as GKE Cloud Router and leave the rest as default. Now go ahead and click on Advanced Configurations. Click on Enable Dynamic Port Allocation. Leave everything as default and click on Create. Here we go. Our CloudNet is successfully created. Next, we need to enable private service connection. We need to enable this feature to work with Cloud SQL, which we'll be setting up in a while in a private network. Let's begin by searching for VPC. Click on Default. Click on Private Service Connection. Click on Enable API to activate Service Networking API. Once API is enabled, click on Allocate IP Range. IP range should be automatic and prefix length set to 16. IP range has been successfully configured. Let's now go ahead and enable private connection to services. Click on Create Connection. Select GKE internal IP which we created earlier and click on Connect. Our private service connection is successfully created. Now we will proceed and create our cloud database. Click on Create Instance, select MySQL, add the necessary information, provide instance ID, provide a strong password, and pick the version as MySQL 8.0. We will choose the development environment as our configuration. This is a tutorial. We can easily start by experimenting with the database, but this is not suitable for the production workload. Set zonal availability to single zone. We will go with the standard machine type with 1 CPU and 3.75 GB of RAM. For storage, we'll go with HDD. Its performance is not great compared to SSD, but this is more than enough for our testing the application. Uncheck Enable Automatic Storage Increases. Now under Connection, click on Private IP. Under Instance IP Assignment, Network will be default. Allocated IP range is going to be GKE internal IP, which we created earlier. Under Data Protection, uncheck Enable Deletion Protection and Automatic Backups. Under Data Protection, uncheck Enable Deletion Protection and Automatic Backups. We are pretty good now. Go ahead and click on Create Instance. It will take a couple of minutes to initialize the database. Once the database is successfully initialized and it's up and running, then click on Databases section and create a new database. Provide the necessary information and click on Create. The database is successfully created. Now we are going to store our Docker images in the artifact registry, the next generation of container registry, which store, manage and secure your build artifacts. If you are using this API for the first time, then you need to enable it. This is a one-time operation. Click on Create Repository. Provide the necessary information. The format is going to be Docker, mode is going to be standard, location type is region, and region will be Asia South 1. If you have observed in the format section, it has multiple support like Docker, Python, Maven, etc. That's why it's an universal build artifact tool. Now go ahead and click on Create. Our cluster has been successfully created. Let's connect to the cluster and verify everything is working fine. Click on cluster 1. Click on connect. Copy the command. Click on run in Cloud Shell. A Cloud Shell will be initialized and the command will be copied to the terminal. Once you press enter, you need to authorize it. Run the following command kubectl get nodes. This will provide the list of 3 nodes currently running in the GKE cluster. Now I will try running a simple Nginx pod just to verify everything is working fine. The Nginx pod is running perfectly fine. Now let's move ahead to the PyCharm terminal. As spoken previously, the command which you ran in the Cloud Shell, now run the same command in your PyCharm terminal. This will be initialized and create a kubeconfig entry of the GKE cluster. I am going to run the following command kubectl config get context. This is going to give the list of multiple clusters. We have 2 clusters attached. One is local Kubernetes running through Docker desktop, and the other one is the GKE cluster which is currently associated. You can now easily check the list of nodes in the cluster by running the following command kubectl get nodes. Let's now move ahead and edit our configuration. Click on the 3 dots to pick the Google Cloud project. The project will get automatically detected. You just need to click on JetBrains and click OK. Click on the reload icon to refresh and repository name will appear. If you remember, we created the repository in the artifact registry. Under Build or Deploy, make sure to choose Google Cloud Build. The Docker image will be built directly in Cloud Build instead of running it locally. Once done, click on Apply and then OK. Now go to Google Cloud Console and search for Cloud Build. You need to enable the API to use Cloud Build in your project. Now moving ahead, we need to obtain user access credential via a Webflow and put them in the well-known location for application default credentials. Run the following command in the terminal: gcloud-auth application default login. If you want to interact with GCP via SDK, you need to run this command. Once authenticated, you will receive a similar kind of message in the terminal. Now go ahead and start the build process. The build process has been initiated and it is getting executed in the Google Cloud Build. If you want, you can also execute it locally through Docker Desktop or Minikube. The application went through the following step. First, the build process was initiated, then the image was deployed to the registry, and then finally pods were deployed and exposed through service via load balancer, and the request proxy through the localhost on port 4503. Finally, the page is loaded and this is how the UI is going to look. As you can see, a Django pod is running in the default namespace. You can see the pod IP is private and it's being exposed through the load balancer service on IP 34.100.240.93. You can directly open this IP on the browser and there is no difference between accessing through proxy. You're directly connected with the public facing load balancer. If you stop the running process, then the deployment and service will be deleted and the IP will also be released. So if you run the application again, then you will receive a new load balancer IP. Go ahead and add this line db.sqlite tree in the docker ignore file as we are going to use MySQL. So I don't want this file to be added to my image. This is the cloud database that we created earlier. Make sure to copy the private IP address. Open the settings.py file and add the following code in the databases which support MySQL and make sure to change the host to the private IP which we copied earlier. Now open requirements.txt and add MySQL client. Make sure to add a version to avoid compatibility issues, otherwise it will always pick the latest version. Now open Docker file and add the following lines to install MySQL connector. After you have made the necessary changes, rerun the application. Once your app is up and running, you need to get inside the container and run the database migration. Run the following command to get inside the container. For database migration, run the following command python manage.py migrate. You will observe that migration is getting applied successfully. As you know, we have rerun the application again, so the public facing load balancer IP has changed. Our migration is done and the application is running fine. Let's now test our APIs. I will perform all the CRUD operations. In the delete method, we don't receive any response. The status code we get is HTTP 204 no content. This is how the to-do list is going to look in the browser. Now let's move inside the PyCharm and explore the features provided by the Cloud Code plugin. Click on Cloud SQL pointing in the right sidebar. Now click on Cloud Sample DB. You can observe we don't have any public IP address. To view the tables or database information, we need to enable the public IP to access it externally. Move to Google Cloud Console, click on Cloud Sample DB and then click on Edit. Now under Connection, check on Public IP. Under Authorized Network, create a new network, provide CIDR notation of 0.0.0/0. Once done, apply the changes. It will take few minutes to update the configuration. And finally, you will see the public IP address appearing in the UI. Now move back to PyCharm and reload the Google Cloud database. You will observe now the public IP is appearing. Double click on Cloud Sample DB, it will start installing Cloud SQL dependencies. Once your instance is connected, click on Create New Data Source. You don't have to configure anything over here, just make sure to download the missing driver files. Once the driver is successfully installed, make sure to click on Test Connection. This is to verify everything is working fine as expected. Now click on schemas and check on hello world_db and then click on apply and then OK. Now wait for a few seconds and the entire schema will be loaded. Double click on the table to-do_to-do list and you can see the table rows and columns appearing. So deploying the application in GKE's cluster is finally done. So let's try to give a final touch by trying to add a new domain to our application. We'll go to Google Cloud Console and search for cloud domains. If you are using it for first time, make sure to enable the API. Click on Cloud DNS on your left sidebar. Click on Create Zone. I'm going to register a DNS record of the mukul.click domain. This domain is purchased from a third-party domain registrar. Provide the following details as shown on your screen. You will need to provide your own domain name under the DNS name. The DNS records have been successfully created. Go ahead and click on mukul.click of type NS. Below you see the 4 DNS record which needs to be updated in the third party domain registrar. As you can observe, the domain is registered with Namecheap. I have updated the DNS. Just for your information, the DNS propagation takes around 24 to 48 hours. Sometimes it may take less. If you have purchased your domain from GoDaddy or some other registrar, then the process will be same but the UI will be different. Now go to VPC networks. Under IP address, click on external IP address. First, we need to create a static public IP address and then we are going to use it with the Ingress. You need to point your domain to the static external IP. Go ahead and click on Reserve External Static IP Address. This is the UI from which you can create a static IP address. Otherwise, you can run through the CLI as well. I'm going to create a static address from the CLI. Run the following command in the terminal. Just refresh the page and you will observe the newly created static IP. Go back to PyCharm and open hello.service.yaml file. Change type to node port and change port to 8080. To work with Ingress, the service type has to be node port. Under project root, create a Ingress folder and under it create a file ingress.yaml. Now PyCharm provide excellent support for Kubernetes. So there is a plugin for that. So click on PyCharm, click on settings. Under plugins, search for Kubernetes and click on install. This plugin is going to help you a lot while working with Kubernetes manifest. Observe carefully line number 7. You need to provide custom annotation to use your published static IP which we created earlier. Next, we are going to create a managed certificate object. This resource specifies the domain for the SSL certificate. Wildcard domains are not supported. Now you need to annotate the managed certificate in the ingress.yaml file. Now we will create a frontend config object. Frontend config can only be used with external ingresses. The frontend config actually redirect all requests from HTTP to HTTPS. After you are done, you need to annotate it in the ingress file. Now go ahead and create a new record in Cloud DNS. I'm going to create a new record for demo.mukul.click, and under the IPv4 address, I will provide the public static IP address which we created earlier. I'll perform a NS lookup to cross verify, and it seems to work fine. I will go ahead and apply all the manifest created under the Ingress directory. As you can see, the Ingress and Managed certificates are under provisioning, and it will take a couple of minutes to be active. Meanwhile, run your application, so we just need to wait for the Ingress and the certificate to get provisioned. It took a good amount of time to provision the certificate. For a managed certificate, it will take somewhere around 60 minutes. Sometimes it might take less than 10 to 15 minutes. Now let's open the browser and visit demo.mukul.click. Awesome, it's working. And along with that, it is also doing the HTTPS redirect. So I'll go ahead and perform the same basic CRUD operations again. Now what I'm going to do, I will try to do a small modification in the post request by adding an extra statement. If you can observe line number 18. Previously it was data received. Now I appended thank you. As soon as I save the file, the image build process is triggered. Once the build and deployment are done, go back to Postman and perform the post request. You can see the return response has been changed. So everything is working fine. So this was the entire journey of working with Google Cloud Code plugin. I hope you really liked it. So this is going to be a bonus video on Cloud Run. This won't be a deep dive tutorial. We'll just showcase how things work with Cloud Run at 10,000 feet. So Cloud Run is a managed compute platform that lets you run containers directly on top of Google's scalable infrastructure. You can deploy code written in any programming language on Cloud Run if you can build a container image from it. To know more about Cloud Run, visit the official documentation. Let's begin by creating a new project. Customize the project name to Hello World Cloud Run. Select Django. Click on Create. You can follow the README file which has included all the steps required to run the project. There are some default views already created like the home page and about page. Now let's go ahead and try to modify the run debug configuration. For authentication, make sure to check on allow unauthenticated invocation. Under build settings, choose cloud build. Region is going to be Asia South 1. Under advanced revision settings, change maximum number of instances to 3. Make sure to reduce the number of instances, otherwise you might receive a compute quota limit error. Now go ahead and run the project. You can observe the terminal the build process has been initiated. Just wait for a couple of minutes. Once everything is done, you will receive a working URL. The app has been deployed and it's working fine. If you observe, it's even SSL secured. This is the response from the About page. To dig deeper, you can visit Cloud Run in your GCP console. Not only that, but Cloud Run also captures Django logs seamlessly. Cloud Run is a managed platform and it can do a lot of things. I highly recommend following the official documentation provided by Google. I hope you enjoyed the workflow. It was a sneak preview, but do explore it more. There are tons of features provided by Cloud Run.